Every financial crisis begins the same way. A dashboard turns yellow. No one panics. Everyone assumes someone else is watching the right metric. And then, faster than any committee can respond, the system moves. Liquidity evaporates. Economic assumptions break. Risk signals contradict each other. Supervisors start asking questions before leadership has answers. This is the modern financial system. It moves at machine speed, and humans still govern it at calendar speed. Let me take you back to a moment most institutions still do not understand. A single upstream decision, a duration mismatch, a model recalibration, an incentive misalignment, or a routing rule nobody revisited, triggered a chain reaction. A chain reaction that moved through pricing, capital, liquidity, fairness distribution, portfolio stability, and reputation. Before anyone realized the system was already in motion. This is not a story about one bank, or two banks, or a single failure. This is the story of structural fragility baked into the architecture of modern finance. And here's the part that most leaders, yes, even on Wall Street, still get wrong. These institutions didn't fail because the math was wrong or because the risk teams were careless or because the governance forums were asleep. They failed because no single leader had the cognitive range to see the entire system. Not the math, not the economics, not the regulatory logic, not the architecture, not the propagation pattern. Nobody saw how one decision becomes 10 risk and how 10 risk become a crisis. This is the question every institution should be asking itself right now. How do we govern a real-time, multi-agent, model-driven financial system with leadership structures designed in the 1990s? Because the truth is uncomfortable. The system evolved, but leadership archetypes did not. In an environment where models, decision agents, and automated workflows operate continuously, coherence is no longer optional. Coherence is the new liquidity. Coherence is the new risk control. Coherence is the new competitiveness. Welcome to episode 03, the Quant Human. Let's get to work. Here's the part nobody talks about in earnings calls, investor decks, or regulatory hearings. Modern financial institutions were not designed for the world they now operate in. Not culturally, not technically, not architecturally. and definitely not cognitively. We built today's financial system on the assumption that risk propagates slowly. Oversight happens in meetings. Human judgment can keep pace with system behavior, and committees can prevent cross-domain mistakes. Those assumptions are now false, dangerously false, because the design flaw is baked into the architecture of nearly every major institution. The system is real time. The governance is not. Let me show you what that means in practical terms. A modern financial institution now behaves like a living, interdependent organism. A model recalibration and fraud creates a shift in approval velocity. That shift affects credit conversion, which alters unit economics. Unit economics affect expected losses, which affect capital consumption. Capital consumption reshapes liquidity buffers. Liquidity buffers influence risk-weighted asset volatility, which triggers supervisory questions. And supervisory questions reshape reputational signals in the market. All of that, every step I just described, can happen before the next governance meeting even appears on the calendar. This is a hidden design flaw. Human institutions are still structured like the world is slow. The system they operate is now fast. Very fast. Think about it. Fraud models retrain in minutes. Marketing agents optimize in real time. Eligibility engines evaluate signals continuously. Underwriting models adjust based on live telemetry. Routing logic adapts to congestion and risk patterns on the fly. We now run financial infrastructure at machine speed, but govern it at meeting speed. It's like using hand signals to coordinate a high-frequency trading desk. And here's the uncomfortable truth that most banks quietly acknowledge but never say aloud. The failure isn't in any one team. It's in the architecture of cognition itself. You cannot govern cross-domain, real-time, model-driven systems with siloed expertise and periodic forums. You cannot manage propagation risk with human bandwidth that was designed for a different era. And you cannot expect committees to recognize patterns that span mathematics, economics, supervisory logic, and systems behavior without someone who understands all four domains simultaneously. This is why institutions keep getting surprised. Not by the math and not by the markets, but by the system they built. We created machines that operate at the speed of inference, but leadership frameworks that operate at the speed of deliberation. That mismatch is the hidden design flaw, and it is widening. Every quarter, every launch, every model update, every new agentic workflow. In the next session, we're going to dismantle really one of the biggest misconceptions in the industry. And that really is the assumption that someone, a generalist, a strategist, a smart operator, can just keep it all in their head. They can't. And that myth is risking billions. Let's talk about the archetype everybody misunderstands. Before we can talk about the Quant Human, we need to clear the debris of a very old assumption. Because every time I describe this archetype to someone in banking, I get the same reaction. Oh, you mean a generalist? Or like a hybrid operator? Someone who's good at a little bit of everything? No, not even close. That is the single biggest misconception in modern finance. And it is preventing institutions from solving the very fragility we just exposed in the last session. Let's dismantle this myth the way you'd dismantle a bad model. Open the hood, inspect the logic, and test every assumption. Number one, the generalist myth. Generalists are valuable. They span domains. They connect people. They can hold multiple ideas at once. But here's the truth no one says out loud. Generalists don't integrate domains. They hover across them. They summarize them. They build narratives about them. But they do not sit inside the mathematics while simultaneously modeling the economics, while simultaneously seeing the supervisory implication, while simultaneously understanding how the system behaves in real time. That is not their cognitive architecture, and it's unfair to expect it. And really, it's dangerous to assume it, because institutions are mistaking cross-functional awareness for cross-domain integration. Those are not the same thing. Number two, the specialist trap. Specialists are brilliant, essential even, irreplaceable. But they see the world through depth. Depth in fraud, depth in liquidity, depth in credit, depth in model governance. Depth is necessary, but depth is not coherence. Specialists tell you what is true in their domain. They cannot tell you how that truth propagates across 6 other domains. That's how institutions get blindsided. The fraud team succeeds while creating credit distortions. The credit team succeeds while creating capital volatility. The marketing team succeeds while creating fairness exposure. The model team succeeds while creating reputational risk. Everybody wins their piece, and the institution loses the whole. Not because anyone failed, but because no one was designed to see the entire system. Number 3, the false generalist versus the true integrator. Let me give you the distinction that changes everything. A false generalist knows a little about many things. They stitch together summaries. They create narratives about how things might connect. A true integrator, the Quant Human, thinks in the connective tissue itself. They don't ask, what does this model update mean for the fraud team? What they will ask, what does this update mean for approval velocity, for unit economics, for capital formation, for liquidity buffers, for fairness distributions, for the supervisory control stack, and for the real-time behavior of the entire system. It is a different cognitive engine entirely. Put plainly, generalists unify people. Quant Humans unify systems. Generalists facilitate. Quant Humans synthesize. Generalists translate. Quant Humans integrate. That difference is not semantic, it is structural. Number 4, why this misunderstanding is dangerous. Because every institution right now is trying to solve AI area fragility with yesterday's talent archetypes. They think we'll put a generalist in the middle. We'll put a strategist on top. We'll put a committee around it. But real-time risk does not wait for human governance cycles. Multi-agent workflows do not slow down to match organizational culture or organizational structure. Capital markets do not pause because your committees meet monthly. If no one can integrate the math, the economics, the risk posture, and the architecture, the institution will always be surprised by its own system. Not because the people aren't smart, but because they weren't designed for this category of complexity. And number 5, the setup for what comes next. We are about to step into the next conversation where the system actually breaks. Not in the abstract and not in theory, but in the very real chain reactions that happen when one model update, one routing change, one threshold shift spreads across an entire institution faster than anyone expects. And that is where the need for the Quant Human becomes undeniable. The next conversation is where the shocks start. Here's the part of the story most institutions still don't understand. Systems don't break at the point of failure. Systems break at the point of propagation. Failures don't happen where the spark begins. They happen where the spark travels. And in modern finance, where decisions are made by models, propagated by APIs, interpreted by multiple agents, and executed in real time, a tiny shift in one domain can become a supervisory event before anyone even knows something changed. Let me show you exactly how that happens. Let's begin with something small, something that seems harmless. A model update, a threshold adjustment, a routing tweak. Maybe the fraud team tunes a variable. Maybe the underwriting team recalibrates a probability band. Maybe marketing adjusts an eligibility flag. Tiny moves, ordinary moves, routine moves. But in a multi-system institution, nothing is ever isolated. Not anymore. I'll walk you through a real propagation chain. The kind the white paper that I will publish analyzes in depth. This is how a system actually breaks. A variable intended to improve fraud precision accidentally shifts approval rates for a demographic cluster. Nobody catches it in real time. Why? Because monitoring happens monthly. Fairness reviews happen quarterly. And system behavior moves continuously. Approval rates dip for high loan-to-value customers, but rise for high-loss customers. The portfolio starts absorbing silent risk. Finance notices the loss curve bending, but doesn't know why. Internal capital forecasts tighten. Expected loss projections inflate. Risk-weighted access volatility increases. And this is where regulators start paying attention. Funding teams see shifts in utilization. Stress buffers tighten. Liquidity windows narrow. The bank looks twitchy in the interbank market. Not distressed, just off. And in capital markets, off is dangerous. Rates move. Partners ask questions. Internal committees scramble. The institution starts losing the most valuable asset it has. And what do you think that is? Let me answer that. It's confidence. The most valuable asset the institution has is confidence. When supervisory teams run their anomaly scans, they see unusual patterns in approval distributions, capital forecasts, and liquidity signals. And they ask the one question the institution cannot answer. Where in your system did this begin? None of this is caused by malice. None of it is caused by incompetence. None of it requires a major failure. It happens because each team sees its own sliver of the system. Fraud sees fraud. Underwriting sees underwriting. Marketing sees acquisition. Risk sees controls. Finance sees capital. Compliance sees fairness. Engineering sees architecture. Individually, they're right. Collectively, they're blind. Because in a real-time institution, domains don't operate in parallel. They operate in sequence. Each decision becomes the next system's input. This is what the white paper that I publish calls cross-domain propagation risk. And it's the silent killer of modern financial systems. Here is the part nobody wants to admit because it hits too close to home. Institutions are not designed for the reasoning demands of real-time finance. Not the people, not the committees, not the governance cycles, not the structure. The system moves faster than the institution thinks. That is the hidden design flaw. Not the models, not the AI, not the technology. The cognitive architecture of the institution does not match the speed and interdependence of its own systems. And that mismatch is where fragility is born. The next conversation is the diagnostic. The MRI scan of how institutions actually fail. The next conversation is the pivot. It introduces the structural solution. It introduces the structural solution, the one archetype built to reason across the entire propagation chain. We move from here is why the system breaks to here is the only cognitive model that can manage this level of interdependence. The next conversation will take us into the 4 layers of the Quant Human: mathematical, economic, regulatory, and architectural, and how they create coherence where institutions have only had fragmentation. This conversation is the diagnostic, the MRI scan of how institutions actually fail. The next conversation is the pivot. It introduces the structural solution, the one archetype built to reason across the entire propagation chain. We move from here is why the system breaks to here is the only cognitive model that can manage this level of interdependence. The next conversation will take us into the 4 layers of the Quant Human: mathematical, economic, regulatory, and architectural, and how they create coherence where institutions have only had fragmentation. If the last conversation was the diagnosis, this part of the conversation really will serve as the anatomy, because the question every institution eventually asks is, who can actually see the entire propagation chain? Not the model, not the team, not the committee, not the policy document. A propagation chain is a cognitive phenomenon, a system level phenomenon, a multi-domain reasoning phenomenon. And only one archetype, one cognitive design, can operate across all 4 domains that drive modern financial risk: mathematics, economics, regulation, systems. That architecture is the foundation of the Quant Human. Today I'm going to walk you through the 4 layers of that cognitive model, each one illustrated with a cinematic micro example drawn directly from the companion white paper. Let's begin. If you want to understand why institutions drift, you have to start with the math, because the math is where system behavior begins. A quant human can see feature lineage, drift signatures, proxy variable risk, model monotonicity, meaning the prediction moves in a consistent logical direction when an input increases or decreases. Data behavior correlation, fragility in decision boundaries. Not at the end, not during audits, but in real time. Let me give you the cinematic example. A fraud team adjusts a single proxy variable to reduce false positives. Perfectly legitimate move, well-intentioned, but the new variable behaves differently for different demographic clusters. On paper, it improves fraud precision. Inside the system, it triggers a distribution shift that underwriting never sees, because underwriting doesn't know fraud change the upstream signals. So what happens next? Approvals fall for high loan to value, low loss customers. Approvals rise for low loan to value, high loss customers. Expected loss curves bend. Unit economics distort. Capital forecast tighten. Supervisory attention increases. And all of it starts with a single mathematical shift. The institution is not cognitively structured to see. A quant human sees that shift immediately because layer 1 is their native language. And then we have something we call a layer 2, economic and financial reasoning. Really, it serves as, we call it the engine beneath the system. So, just to reiterate, layer 1 was the mathematical and algorithmic reasoning. Layer 2 is the economic and financial reasoning, again, the engine beneath the system. And here's the part people underestimate. Models don't make predictions. Models make economics. Every threshold, every regression boundary, every incentive band, every eligibility rule reshapes capital, liquidity, profitability, and risk-weighted assets. A quant human thinks in economic propagation, not just model accuracy. And here's the cinematic version of that. A product team adjusts an underwriting threshold to increase approvals. The uplift looks good. Acquisition jumps. Conversion rises. Marketing celebrates. However, behind the scenes, loss rates increase at a disproportionate rate. Expected loss curves steepen. Capital consumption rises. Risk-weighted asset volatility increases. Liquidity buffers narrow. Approval patterns appear unnatural to regulators. The model didn't just change performance, it changed the institution's balance sheet. Most teams never see this until it's too late. Quant humans see it instantly. Because layer 2 is their map of the engine. Then we have a layer 3. Layer 3 is called the risk and regulatory reasoning. It is known as the institution's operating license. Every model is ultimately a regulatory argument. Not explicitly, but functionally, rather. Excuse me. Regulators, they don't audit code. They audit consequences. Regulators, they ask the following types of questions. What population is affected? What is the distributional impact? What is the capital effect? What is the supervisory trigger? How does this model behave under stress? How does it interact with other models? Most institutions can answer one or maybe two of these questions. They generally cannot answer all six coherently. However, a quant human generally can. Let me make this cinematic. Marketing optimizes a personalization algorithm. It slightly increases acquisition in a young, high-growth segment. However, in the process, it subtly reduces exposure to an economically disadvantaged segment. Not intentionally and not maliciously, just simply mathematically. Over the course of 3 weeks, the approval distribution shifts. The adverse impact ratio decreases. Complaints rise. A regulator's monitoring system flags the pattern. Supervisory teams ask the fatal question. Explain exactly how this model creates distributional impact. A quant human answers in minutes. Why? Because layer 3 is their regulatory reasoning engine. Then we have a layer 4, systems and architecture reasoning. This is known as the propagation layer, and generally it's the most important layer of all. This is where everything comes together. Because institutions do not fail inside a single model. They fail in the distance between models. They fail in the propagation. A quant human maps API dependencies, real-time routing behavior, drift propagation paths. Multi-agent interaction, upstream and downstream coupling, cross-domain exposure, failure modes across the entire decision spine. Let me give you the cinematic moment. Engineering adjusts a real-time routing rule to balance system load. Again, perfectly reasonable. Perfectly rational. But that routing rule alters the distribution of applications, the fraud pattern, the approval cadence, the settlement timing, and ultimately the liquidity profile seen by Treasury. One routing change, dozens of downstream impacts, nobody notices because no team owns the entire chain except a quant human who sees the architecture as a single living organism. Each layer is powerful on its own, but the structural advantage comes from integrating all four. Mathematics without economics causes distortion. Economics without regulation causes blind spots. Regulation without systems logic creates misalignment. Systems without math create fragility. Only a quant human operates across all four simultaneously. and that is the cognitive architecture. Modern financial institutions were missing when Silicon Valley Bank and First Republic failed. This is the archetype designed for real-time, multi-agent, model-driven finance. This is the centerpiece of this entire episode and the bridge to the next part of our conversation. If the first half of this episode explains why systems break, this part of the episode explains why institutions stay broken and what the Quant Human does that current structures simply cannot. Because here is the uncomfortable truth. Most financial institutions are built like collections of high-performing parts, but supervised like a single machine. And the distance between the parts and the machine is where the risk lives. Let's make this real. In most banks, marketing has one truth. Underwriting has another. Fraud has its own. Finance has a fourth. Compliance and risk has a fifth. Each domain optimizes locally. Each domain reports vertically. But customers, markets, and algorithms behave horizontally. So, when a model shifts even slightly, the institution does not perceive the ripple as one event. It perceives it as 5 independent anomalies, each through a narrow aperture. That is not a governance problem. That is a perception problem masquerading as governance. Institutions need one integrated decision spine, a longitudinal structure that connects how data enters, how models transform it, how economics interpret it, how risk governs it, and how systems propagate it. This is not about adding more committees. It is not about adding more dashboards. It is not about adding new layers of approval. It is about upgrading the institution's cognitive architecture. A governance spine is the structural equivalent of giving the organization a central nervous system. One signal in, one coherent interpretation out. Here is the pivotal insight. The governance spine is not just a set of frameworks. It requires a type of mind capable of connecting the math, the economics, the risk logic, and the system behavior in real time. A Quant Human functions as a cognitive convergence hub inside this architecture. They see how a routing model misalignment becomes a fraud spike. They see how a fraud spike becomes an inclusion distortion. They see how an inclusion distortion becomes a capital anomaly. They see how a capital anomaly becomes a supervisory concern. Before risk escalates, before finance feels it, before the model validation team runs a monthly review, before the board asks, why didn't we see this coming? The Quant Human sees it in the architecture itself. If the systems of the last decade were fast, the next decade's systems will be autonomous. Multi-agent decisioning, autonomous workflows, routing engines that dynamically adjust without human prompting, fraud defense agents that negotiate outcomes with credit models, pricing agents that explore incentives based on behavioral telemetry. These systems do not break in slow motion. They break at machine speed. And here is the key danger. If the system is agentic, but the governance is not, you have built a self-accelerating failure mechanism. A quant human counteracts that risk by redesigning governance to match the speed and topology of agentic decision-making. Cross-agent escalation logic, bounded autonomy, reward alignment structures, containment paths when agents diverge, supervisory overrides that operate at machine cadence. This is governance for the next frontier. A fusion of prudential logic and systems design. One of the biggest misconceptions in financial institutions is the idea that more governance slows us down. But the governance spine, when built correctly, does the opposite. It accelerates execution because the institution spends less time cleaning up model drift, less time reconciling inconsistent metrics, less time explaining anomalies to supervisors, less time resolving inter-team disagreements, less time unwinding decisions that propagated across systems. Governance becomes a competitive advantage because the organization no longer loses energy to incoherence. The quant human doesn't slow the system down, they make the system coherent. And coherence is what reduces fragility, strengthens control discipline, and unlocks durable innovation. And that brings us to the moment we shift from concept to evidence. Because these ideas aren't theoretical, they've played out painfully in real institutions. And in the next part of the conversation, we walk through 5 failures that became design lessons. A capital signal no one interpreted correctly, a payments routing cascade, a multi-agent fraud underwriting conflict, a regulatory documentation mismatch, and the end-to-end marketing ecosystem redesign that became the turning point for the entire companion white paper that's published with this publication, this podcast. The next part of the conversation is where the architecture meets the real world. Let's go there. You've now seen the architecture. You understand the layers. You understand why the system breaks. So now let's go to the places where it actually broke. These are not hypotheticals. These are real institutional failures that left scars. Failures that cost billions, triggered supervisors, and revealed the exact structural gap the Quant Human is designed to close. Let's walk through 5 failures and the design lessons they forced the industry to learn. Let's talk about failure number 1. A large lender saw approval rates drifting upward in one specific digital funnel. Marketing celebrated. Underwriting, they shrugged. Risk just assumed it was seasonal. Finance saw a slight uptick in expected losses, but not enough to sound an alarm. Individually, each team saw something plausible. Collectively, they missed the signal. Because what was actually happening was this: a single segmentation feature inside a conversion model started overweighting a thin slice demographic with higher probability of default volatility. That volatility fed into expected loss. Expected loss fed into capital allocation. Capital allocation fed into risk-weighted asset sensitivity. No one synthesized the entire propagation chain. So it wasn't a math failure, it was a systems coherence failure. So what's the design lesson here? It's this: if no one is responsible for connecting the dots, in other words, if no one is responsible for connecting the model, the economics, the capital to the supervisory chain, then nobody is responsible for the system. And this is the first domain where a quant human changes the trajectory. So let's talk about failure number 2, a payments routing cascade. A payments platform introduced a real-time routing update that was designed to lower network fees. The idea was simple: route more transactions through the lowest cost rail. But the model powering the routing logic began misclassifying which transactions were safe to down tier. What looked like a pricing optimization quietly became an operational risk escalation, because the downgraded transactions had a higher likelihood of settlement delay. That delay triggered liquidity timing mismatches. Those mismatches triggered reconciliation irregularities. Those irregularities triggered supervisor attention. And here's the kicker: it took 3 months for anyone to see the connection between the routing change and the liquidity side effects. So what's the design lesson here? Operational risk is now mathematically generated. And if you do not have cross-domain reasoning, you do not see the system until after the damage is done. This is where the systems and architecture layer of the Quant Human is structural and not optional. So let's look at let's look at failure, the third failure. The third failure is related to a fraud underwriting conflict. This is a true multi-agent failure. Fraud deployed a new anomaly detection agent. Underwriting deployed a new credit limit model. Each project was independently greenlit. Each passed its individual validation tests. But when both went live, something subtle happened. Fraud tightened its thresholds. Underwriting loosened its thresholds. And neither team knew the other had changed their policy surface. So what was the result? Well, a spike in false approvals. And then, of course, a spike in unexpected defaults, followed by a spike in fairness complaints, because the combined effect created disproportionate approval volatility across demographic segments. Everyone, of course, blamed everyone else. When examined, however, the real failure was simple. No institution-level synthesis. No unified view of the agent behaviors. No cross-domain model reasoning. So what is our design lesson here for this third failure? Of course, you've guessed it, I'm sure. Agentic systems cannot be supervised in silos. They must be supervised as systems. This is exactly why the Quant Human architecture was designed. Cannot be supervised in silos. Alright, let's look at a fourth failure. This is related to a documentation and interpretability breakdown. A bank built a new machine language-based credit expansion initiative. The model worked brilliantly in pilot testing. The business approved the rollout. And however, when regulators requested documentation, the model card was incomplete. Feature lineage was unclear. Explainability was inconsistent. And the decision pathways were not traceable. Regulators did not object to the model itself. They objected to the opacity of the model. Because, of course, opacity is risk. And when the review escalated, the institution realized something uncomfortable. They did not have a single person who understood the math, the economics, the regulatory expectations, and the system constraints. regulators called this out explicitly. So what's our design lesson here? In the AI era, documentation is not administrative. Documentation is governance. Documentation is risk control. And only a cross-domain mind can produce it coherently. Only a cross-domain mind. Okay, let's look at a fifth failure here. Our fifth failure it kind of serves as a flagship case study here. It's a is related to a marketing ecosystem transformation. A mid-sized lender believed that it was performing well. Strong acquisition, strong funnel metrics, strong conversion numbers. Except the portfolio economics, for some reason, told a different story. Fairness drift emerged unexpectedly. Capital consumption rose faster than growth. And supervisors began asking uncomfortable questions. The problem was hidden upstream. The marketing models were optimizing for conversion, not lifetime value, not expected loss, not capital alignment, and not distributional fairness. Underwriting was unaware of the upstream signals. Finance was unaware of the segmentation logic. And compliance, of course, is unaware of the uplift model behavior. Everyone in a silo saw their domain. Nobody saw the entirety of the system. The intervention required mathematical rebuild, economic reframing, risk reintegration, and systems realignment into a single governed decision spine. And this became the turning point. So what's our design lesson here? When you unify the mathematics, the economics, the oversight, and the architecture, you unify the institution. You restore coherence. You reduce fragility. And you regain supervisory confidence. So, those are the 5 failures that became design lessons. Not because the systems were faulty, but because the thinking architecture inside the institution was built for an earlier era. Now, let's pull these lessons upward. Let's talk about what they mean for strategy, for governance, for talent, and for the future shape of financial institutions. The next part of our conversation is where we talk about implications. And let's move there. You've now seen the failures. You've seen the patterns. You've seen where the system breaks and where coherence restores stability. So now we zoom out because the implications of everything we just walked through reach far beyond marketing, underwriting, or fraud systems. They reshape what it means to run a financial institution in a world of real-time, model-driven, increasingly agentic workflows. This is where we talk about the system-level consequences. Number one, talent pipelines are about to change. Most institutions still recruit for analysts, data scientists, product owners, and risk managers as separate tribes. But the problems we examined today do not live in silos. They emerge in the seams, in the blind spots between functions, where no single role has authority or visibility. The Quant Human changes that. Institutions will need talent that can read a model card, understand unit economics, anticipate fairness exposure, see architectural propagation risk, and translate all of it into supervisory language. This is not a job description. This is a structural requirement. Number two, governance must become coherent, not categorical. Right now, governance frameworks are still built around categories. Marketing governance, model governance, fraud governance, data governance, risk governance. But the system level failures we walked through do not respect these categories. The regulatory world is slowly converging toward the same conclusion. The next generation of governance is integrated, not indexed. It has a single decision spine. It has cross-domain visibility. It embeds risk upstream, not downstream. And it supervises systems, not components. This is the shift the Quant Human accelerates. Number three, cross-disciplinary operating models will replace functional silos. Every case study we walked through had the same root cause. A system behaving as a system inside an institution that was not designed to think like one. The future enterprise cannot afford competing models making contradictory decisions, teams optimizing local metrics, real-time systems governed by committee cadence. The Quant Human is the integrator who ensures that product aligns with risk. Risk aligns with economics. Economics aligns with supervisory expectations. And systems align with the institution's mission. This is not cross-functional. This is cross-domain cognition institutionalized. Number four, regulatory alignment will become a competitive advantage. We need to be direct here, okay? Supervisory expectations are evolving faster than institutional operating models. What regulators want, from the EU AI Act to the MAS, Monetary Authority of Singapore, to BIS, Bank of International Settlements, to the OCC and the CFPB, is increasing clarity that institutions understand how decisions propagate, how models interact, how fairness is maintained, how capital dynamics shift, and how agentic systems are contained. Institutions that cannot articulate this will face escalating supervisory friction. Institutions that can articulate it will earn trust, faster approvals, and strategic room to innovate. Regulatory alignment is no longer a constraint, it is a multiplier. Number 5, fragility reduction is now a core business strategy. Previously, fragility was treated like a risk topic. Today, fragility is a strategy topic. Because when models propagate faster than committees, agents learn faster than governance adapts, and economic shifts happen inside systems, not balance sheets, then stability becomes a competitive advantage. The Quant Human is the stabilizer, the coherence builder, the one who can see ahead of time, where drift becomes distortion, and where distortion becomes systemic risk. Number 6, agentic systems require a new category of supervision. We are entering a world where systems will increasingly perceive, decide, route, optimize, and adapt without human initiation. Agentic underwriting, agentic fraud control, agentic credit line management, agentic servicing operations. The old model of governance by committee packet cannot survive this. Supervisors will demand bounded autonomy, escalation logic, cross-agent communication protocols, multi-agent containment structures, and human override pathways. This is the domain where the Quant Human becomes irreplaceable, because the only viable oversight for agentic systems is someone who understands algorithms, economics, regulation, and architecture all at once. Financial institutions that succeed in the next decade will not be the ones that build the most models, buy the most AI tools, or launch the most features. They will be the institutions that cultivate the rare capability to understand how the system behaves as one interconnected organism. This is the strategic architecture of the AI era enterprise. And this brings us to the next part of our conversation, the forward-looking horizon, where the industry is going, where governance is evolving, where the Quant Human becomes the stabilizing force in a world of autonomous workflows. So the strategic shift is clear. Let's go there. We're going to shift our vantage point one more time. Not into the past, not into the present, but into the financial institution we haven't built yet. The one that regulators, engineers, economists, and product teams are unknowingly orbiting around. Because the truth is this: we are entering an era where the shape of the enterprise will be determined not by speed but by coherence. The next decade of financial infrastructure will not be defined by static models or batch processes. It will be defined by agentic systems, autonomous computational actors that make micro decisions in real time, negotiate with other systems, escalate based on confidence, and learn at a pace that outstrips human oversight. These systems will not run next to the enterprise. They will run through the enterprise. And here's the unavoidable reality. If the institution does not have a coherent human governance spine, autonomy becomes instability. Agentic workflows amplify both excellence and fragility. The institutions that thrive will be the ones that align autonomous decisioning with economic logic, supervisory discipline, and cross-domain reasoning. This is the future quant humans are built for. Regulators everywhere, the EU, Mass Singapore, the BES, are converging on the same idea. Financial stability is no longer a quarterly concept. It is a real-time requirement. That means supervision will shift from reviewing documents to observing behavior, from post hoc model validations to continuous monitoring of decision chains, and from compliance paperwork to governance architectures that prevent propagation risk. The future enterprise needs people who can sit at the intersection of these systems and interpret what they mean as they evolve. That capability is the Quant Human. And so the next operating model really becomes coherence first and speed second. Right now, most institutions still chase speed. Faster onboarding, faster decisioning, faster approvals, faster releases. But here's the shift. Speed without coherence creates fragility. Coherence creates intelligence speed. In the next generation enterprise, marketing and risk will share the same decision spine. Fraud and underwriting won't negotiate, they'll synchronize. Product and engineering won't hand off, they'll integrate. Compliance won't monitor from afar, it will guide upstream design. The future enterprise is not a collection of functions, it is a network of interdependent reasoning systems. This is the operating model Quant Humans intuitively construct. The next leadership archetype will be systemic thinkers. The future of leadership is not charismatic, it is structural. The institutions that dominate the next era will be led by individuals who can read a model the way a strategist reads a map. Read a balance sheet the way an engineer reads a blueprint. Read a system diagram the way an economist reads a cycle. And read regulatory signals the way a designer reads constraints. This is how institutions shift from reactive governance to anticipatory coherence. This is the leadership profile the next prudential decade requires. And so we arrive at the final connective tissue of this episode. The promise of the Quant Human. The Quant Human is not responding to the enterprise we have. They are designing the enterprise we need. A future where real-time systems behave predictably, autonomous agents operate within aligned boundaries, capital is deployed with mathematical confidence, distributional fairness is treated as structural risk, and governance is a living architecture, not an audit trail. The Quant Human is the stabilizer in autonomous environments, the integrator across disciplinary boundaries, and the architect of institutional coherence. This is the future enterprise. This is the future operating model. This is the future leadership archetype. And it is already unfolding. And here is the truth that sits at the center of everything we've covered today. The institutions that win the next decade will not be the fastest. They will be the most coherent. Coherent in how their models reason. Coherent in how their economics align. Coherent in how their risk posture reflects real behavior. Coherent in how their systems work, not as fragments, but as one integrated organism. Because speed without coherence is fragility. Complexity without integration is risk. And intelligence without structure is just noise. But institutions led by quant humans, leaders who can see the math, the economics, the regulatory logic, and the system architecture in one continuous frame, those institutions will not just avoid failure, they will compound advantage. They will build decisioning systems that are explainable, governable, and economically aligned. They will operate faster because their governance is stronger. They will navigate regulatory change because their architecture is disciplined. And they will deploy AI not as a shiny tool, but as structural infrastructure. If this episode resonated, I invite you to go deeper. The full white paper is available now. The companion YouTube webcast drops this week. And the next episodes in Season 01 will expand this foundation into capital markets, agentic systems, and the future of prudential design. Thank you for listening. I'm Lewis Maverick Adams, and welcome to the Aether Vector, where we build the architecture of the next decade.